Hi, this is Purnima Mahalingam, and you're watching video lecture series on solar and wind energy systems. In this, today we are going to see about solar air conditioning, which is harnessing the sun for cooling purpose. Come, let's go into the video. Here comes first part is an empathy part. Here we are seeing that as the globally HVAE demands in set to trip by 2050. The air condition consumes 40% of the building electricity in hot climate. We know that in futures the climate will be so hot. The solar thermal systems often sustainable and the cost-effective cooling solutions. The peak cooling demands aligned with peak solar radiations. We can see the pictures of solar thermal cooling systems. Here we can the solar generations, and we have a solar power plant, we have moisture remover, and we have the evaporator cooling system, and finally we are going with the air conditions. So these are our empathy part. Now coming to the solar thermal system where the energy foundations are. Here we have a solar collector which captures the heat from the sunlight, and we have what are the types of the flat type, which is an efficient of 70 percentage type, and tube type is an 80 percentage, and we have a heat transfer functions via fluid to a storage tank or heat exchangers. And primary usages where are we use in the domestic hot water and space heating, etc. So these are the energy foundations. Now coming to how the solar air conditions works and absorptions and absorption stimulants. Here comes the defined part. So absorptions where the heat to drive refrigeration cycles. So working pair with the lithium bromide and water, and heat boil refrigeration water is which is absorbed by lithium bromine and water. Absorption chillers is here. We have materials is silicon gel and zeolites, and heat generations are absorbent and which is releasing refrigerations. COP typically 0.4 to 0.7 and suitable for low temperature. Here it is benefits of solar air conditions. We have so many benefits. First one is we have seen the reduced electricity, which is up to 80 percentage, and environmental impact, which is an zero direct greenhouse and gas emissions, and peak load shavings and cost savings. So this is a significant lower requirement electricity bill. This is our main aim. And here comes the signification configuration, system configuration, real world applications. Here in these pictures, we can see that we have seen the rooftop solar power plant, which have a standalone system and a hybrid system. We have a standalone system, hybrid system, large scale commercials for buildings and for applications. For residential applications, we have so many, but we have standalone system, the solar thermal directly powered power from for cooling only, and which integrate a hybrid. We have an AC or heat pumping for breakups, and large scale commercial systems where the for commercial purpose of commercial buildings, and we have for another residential building. You can see in these pictures we have on a residential building rooftop solar power plant. And next thing is what are the challenges and limitations we face? There is a first challenge part is longer backup period. We have a longer backup period of typically 7 to 15 years, and performance variability depends upon the solar insulation. Because of the solar insulations, performance can be variability. And next third one is complex. Third part is complexity. The more components and precious control purposes, and space requirement, which is a significant roof area needed for collectors. We need the roof area which is needed for collecting the sunlight, and high initial investment about 2 into 3 into highest upfront cost. Okay, these are the some of the challenges and limitations. Uh, Here comes the market futures, market trends and future horoscope. Outlooks. Here we have 5 to 8 percentage of catch, which is projects throughout 2080, and we have three key regions where South Europe, MENA and South Asian specific, and one technology advancement which is a more compact, high COP chillness and concentrated solar powers, and we have one policy support which is increasing government incentives, increasing government incentive policy support from government. We are getting more incentives for placing the rooftop solar panels, etc. And coming to the conclusion part here, which is in a conclusion part, we have a sustainable path to cooling. We have a powerful solution which reduce the energy consumptions and carbon emissions. That is a plays a main role. And energy conversions. We have an convert solar thermal into cooling. And we have a driving adoptions. We have a policy support address to challenge. We have a critical for decarbonizations. What happened is is green independent in sunrise regions. These are the main 4 points of conclusion. And here comes the summary. Here what happens is summary. Solar air conditions, we have seen sustainability, her foundations. We have solar collector, heat transfer fluid, primary usage. We have in solar AC workers, and what are the key benefits, significant configurations, and challenges and limitation. What are the limitations? 7 to 15 years, and we have a performance variability and complexity, space requirements, and high initial investment, and market trends and future look. I hope you understood this topic. We will meet in next class. Thank you so much for watching.